Hi everyone. Today we'll look at the database encryption. The hands-on will be only on MySQL. So the database security that starts from authentication, authorization, and encryption. So we'll look at today about the encryptions. Encryption is actually needs a key. It could be symmetric key or asymmetric key. So we're going to use symmetric keys. So the same key, the key will be to encrypt and also decrypt. The algorithms that we're going to use, and also the algorithms that's available on MySQL is AES. So we're going to look at this AES, okay? Encryption, in theory, given a relations schema, so table name and a list of attributes, that will be converted to either entire a table to be encrypted, or any attributes in a table to be encrypted. Therefore, the table itself holds some of the keys and cipher encrypted values. This is the given table. If we encrypt, for example, salary and bonus, then we have the Adam. In this case, let's say everything, entire table is encrypted, then everything could be encrypted like this. So it has a counter and the key, and followed by the ID, name, salary, and bonus, all the values there. I mean, this is readable to us right now because that was my purpose. But in the real hands-on exercises on the real MySQL, and then the value that you could see not really has nothing to do with the real actual value. So encryption granules, as you may notice while I was explain, it could be entire table. The entire table can be encrypted, or entire database can be encrypted, or a particular tuple record may be encrypted. More specifically, let's say an attribute can be encrypted. So we'll, as an example, we will look at one attributes to be encrypted. Let's say if this data is sensitive, because this is a salary, then we can encrypt it. Then we will use the encryption, the algorithms. In this case, in our actual database package, it is nothing but a like a function calls. Okay, AES encrypt is a function so that you can have an argument. The first argument is the data, and second argument is the key. So this, the very same key, will be used to encrypt this data. Then, without knowing key, without decrypting this attribute using the key, using the correct key, you cannot read it, right? So we can do AES encrypt. If it is encrypted, then you can decrypt it in order to read it. But in fact, even if you encrypt this, because the type of this data, why? Actual data here, if that is a salary, then there is a floating points. Guess what? If we encrypt this, then the size of the salary will be maximized. It's not just integer size or floating point size. It could be like 255 byte long. No one receives that much money, 255 bytes long number, right? But because of this encryption, we, according to the algorithm, it can be encrypted, therefore the size of the data will be maximized to the maximized sized cipher. Then it will be even harder to decrypt it if any hacker comes in to decrypt it without knowing the key, proper key. So to make it harder to be compromised, then we need to make the size of this very, very long. So when you do simply decrypt it, therefore the type of this is not just integer or double. It could be really, really big size, let's say binary or variable binaries, very, very long data. Even if you decrypt it, because of the type of this salary, it's not yet readable. You have to convert the binary code to a character, okay? So we use some other function called cast. You need to type cast to the character, therefore alphanumeric characters are the readable that we can see, right? Let's assume that user, we have a table user and ID, the key, primary key, and username, name, whatever name, and email, let's say that we intend to encrypt. So email is not really this long, 250 bytes long, right? There is no such long emails. Why we need this var binary? Because we intended to make this encrypted, okay? Then the insert into users is a table. So username and email, I want to put two the values. Then I want to insert two tuples in one insertion statements. One for Alice, the other for Bob. Then Alice and Bob username okay, but email I want to make it encrypt. So AES underscore encrypt, and I put real data. This is actual data, right? And then I can assign my key. Okay, you name it. This is a secret key, so you have to keep it secret, but don't forget it. If you forget this, then you cannot decrypt it, right? So the very same key will be used to encrypt and therefore also decrypt data. So we can use the same key to decrypt. Okay. What if an attribute already defined, and we want to now, at some points later, we change our mind. Hey, that data, that attribute is sensitive, therefore we have to encrypt it. Okay, then you need to alter table, whatever the data. Let's say faculty. Faculty salary is a secret. Initially, it was open, but now we want to modify it. So alter table, modify column, and this is the existing salary column. And then we change the size of the data for binary. Could be whatever the size. 16 is fine. 255 is fine. Okay. If you do not have the attribute, but you want to add a new attribute with the encryption, then similarly, alter table, add a column name, and then type of that column name should be wide enough to accommodate the cipher. Okay, big size. So encryption is same thing. Faculty, then faculty name, faculty salary, and this is a key for that. Oh, this is big money. It's my dream. I'm not sure if I could get this much money in my life before I die. Probably not. I want to keep this dream salary anyway. And then this is the department, okay, cyber. Then if you want to see the select name, department, and the salary name, salary, then you could see something. But if you want to decrypt it, then it could be decrypted for the accurate the key. As I said, this is not enough because initially the type of salary is a binary type. We want to make it to character type, right? So we use cast as character. As you use here, AES decrypt salary as whatever the key, and then we need to cast it as character. Then we can see the value that we originally actually entered the value. This is actual value, right? But when you do this only, still it is not readable. If you want to make it readable, then you need to make this. This is the email case, but you can change this to salary. For entire table encryption, MySQL does not provide, so we don't really discuss it. But there are some way that we can encrypt some. Okay, so encrypt the sensitive columns one by one. We could do something. Okay, if we, although it is not really entire table, but if you want to do each attributes in a table completely, then entire table eventually to be encrypted. Okay, that is something that you could do, but if you want to encrypt a table at once, not possible. Okay, all right, so now we want to do practice. So you need to open MySQL. For my case, oh, not PL. I forgot. Go on top, and then I think it is USR, cd USR local, and then MySQL. So cd MySQL that, and cd bin, then there is a MySQL. So MySQL and username is JYON525, and password also show tables database. So CY525, use CY525, show tables. Okay, I have class, department, and students. Okay. Course top by, okay, class, department, in which one did I want to do here? Let's practice, let's say students. Student has a CWID name and major. Let's assume we want to add pay to students, and pay, because pay is a sensitive attribute, so we want to encrypt it. Okay, then we need to do alter table, and table name student. I want to add column, and then binary, var binary, say 255, and semicolon. You want to check the manual near, add a column, add a column, y, alter table, student, add column, var binary 5. Let's say 16. Still not. Alter table, student. Modify this work. Let's say I want to try if I modify something else. Let's say department. Alter table. Alter table department. Modify column. Name, primary key stat, so name, and then if I say varchar 20. Well, that should work. Student. So is it simply add or add a column? Not sure. I think we should add a column. And then if I say pay binary 255. What was the difference from previous? Alter table student add a column. Oh, I didn't put here pay. That is the reason. Okay. So description of students like that. Okay. So now I want to insert. Insert into student. Values and CWID integer, so 9988, and the name Bob, major cyber, and then pay. You can do AES encrypt, and then my pay, let's say 1,000, and then secret, I would say Bob sec. And I close this function AES encrypt, and I need to close the other ones also. And semicolon. Yes, that's there. So if I do select star from student, then it'll be like this. This is a binary code, right? So this is not readable. How can you then make it readable? Then you need to do, let's assume that we want to see, I don't want to show all others because the others all null. That's okay. Here I want to show name and pay. If you want to do this, it shows like that. But you have to do AES underscore decrypt pay, and then the key was BOBSEC, BOBSEC. Okay, so BOBSEC. All right, looks good, right? Students. So if I do that, then this one was reduced because it's decrypted, and this is the size for $1,000, but this is a binary. I think this is 1000, right? But I want to see this actual value that I entered. Then you need to do here cast, and then that should be, oh, by the way, at this moment this doesn't look good, right? Here it shows pay, and this is no good. In order to show this as a pay, then you need to say as pay. Okay. because of here, that. So you have a pay. So for that, I want to change it to the type. So typecast, that type should be as character, let's say 255, the same character, and hit enter. Then I have the exact ones that I entered, right? $1,000. Okay. So this is the encryption of the database. This shows only one attribute encryptions. If you want to do this for as many as you want to do, then we can include Python code. So Python code can handle multiple times for any conditional statements. That's what we will do, okay? So from next week, we're going to see how Python can help our database, the language executions more efficiently. Okay, so database SQL statements can be executed a lot more efficiently and effectively if we use Python. That's what we will do. Okay. So knowing this, one case of encryption, we can extend this by using Python to maximize. Okay, your next homework assignments is exactly like this. So I want you to show, for example, how you can add an attributes like this. Therefore, you will have new attributes, but the type of that is even wider. To that one, I want you to enter the new values with the value encrypted, and then immediately I want you to show this SQL statements, so it shows, hey, that is encrypted. And then finally, I ask you to show how you can decrypt it. Not only decrypt, but I want you to make a typecast. Therefore, the character types can be shown. The value that you actually entered as you inserted 1,000, right? Therefore, it should be written that way because I entered here 1,000. All right, this is it. See you later.